Hey guys, this is Override from the Open Pilot forums. Today I wanted to make a little video of setting up a tricopter with the Open Pilot CC3D. The flight controller that I'm using in particular is the Atom. I've already got the tricopter set up on my desk. It's plugged in, ready to go. But there's not a whole lot of information on the tricopters yet. People have issues with them, whether that be the yaw mechanism or getting the PIDs tuned correctly, or the tail wagging. There seems to be quite a few different issues that people have come up with that I just wanted to make a little video of how I got mine flying. It flies pretty good. I did a few hours of flying yesterday at my buddy's house. Anyways, I gotta give props to Cnut from the forums. I'm actually going to be using his optune calculator and part of his methods for tuning the tricopter through the TXPID. So from the get-go, you want to come over to your firmware tab and you want to check your bootloader version. This in particular is bootloader 4. Then you're going to go to, you want to make sure you download the correct Open Pilot program. I'm going to be using 15.2.1. It is compatible with bootloader 4, and it's compatible with the CC3D Atom, and I believe it's the latest firmware out for this particular flight controller. So, alright, so you want to go to the vehicle setup wizard. Make sure you read any of the warnings. You want to make sure your props are taken off right now. Make sure you have a flight battery ready to go. Make sure you've got your receiver and transmitter programmed. Make sure you've got your transmitter channels programmed correctly as far as what you're going to be using them for. And then you're just going to go through this. You always want to do erase settings and then click upgrade. And this is going to go through. It's going to erase all of the settings that are possibly on the CC3D. Obviously, if this is your first time setting it up, you shouldn't have any, but still erase all the settings and do an upgrade. It's going to upload the current firmware that you have in your ground control station, which in this case is the 15.2.1, the Raging Cajun. So the board's been updated, all the settings have been erased, so you're going to click next, and this should pretty much already have everything set up, the connection device, and it's detected the board that I'm using. Click next again. If you're using just a basic, say, Spectrum setup, you're going to go with PWM, and then PPM is for, I can't remember the name of it, but basically use one cable to program all of your channels, and then Futaba's S-Bus, and then Spectrum satellite receivers. So we're going to go with PWM, and obviously multi-rotor. You're going to select your tricopter. Don't worry about the orientation of the props in the picture, because you can actually change that later on. So mine is actually reverse of what this is. And then choose your ESCs. I'm using Simon K Lumineer 30 amp ESCs, so they are acceptable with the Rapid ESC 490 Hz rate. I'm using a digital servo. And then you can come over here to connection diagram. You can see what color-coded cables go where. I don't know for sure, but I know my cables are not set up in this color code, and they shouldn't have to be either. So, but you can save that diagram to your computer. All right. Here's a part that I wanted to show, and I'll actually I'll get a video going of it, but we're going to go ahead and calculate this now. Alright, the gyros have been calculated. You want to make sure that your craft is on a flat level surface when you do this. Like I said, I'll clip in a little section of video where I actually show my method of doing things. It seems to work alright. and then you can trim out any drift that you may get. When you're leveling your craft, you can pick up these little bitty levels here for like $1 something each at Walmart, or I'm pretty sure any hardware store would carry them. But I've got 3 of these, and then just a little piece of cardboard tab from something, you know, this is from APC Propeller, and I cut them into little squares like this. I usually use about 2 or 3 of these to get a bunch of these little squares. You're going to need quite a few. Alright, so coming over here to my Tri-Copter, you can see I've already got these set up. This is where mine needed to be level. But put your 2 levels. You want one on your roll axis and one on your pitch axis. I try and get them as close to the center of the frame as possible. I've noticed that going further out on the arms gives you different readings. You can get a different reading from pretty much any different way you can do it. Another way I've also done it is I've got a larger level, which you can also pick this up at Walmart, and I've laid it across the front here and tried to get level off of both arms. I've noticed doing that. It works pretty good. I've yet to get my levels exactly perfect where I don't drift. Like I said, you can go into your ground control station and you can actually set your trim levels on your board, and you can get some drifting that you have left, right, forward, back, out. And I can also show you how to do that later, but just to show you what I'm talking about here a little bit more close up. See that right there? It's pretty well level, as well as this one, and it seems to work alright. So that's my method. You can use whatever method you're familiar with, or something that may work better for your board. I've heard of taking these and actually calibrating your gyros with them sitting on a desk flat. I don't know how well that works. I've never done it that way. So, but we'll get back to the rest of this video and finish going through the setup, and then get to tuning the PIDs. So make sure that you've got your battery ready. You're going to connect the battery to the airframe. You check these 3, click start, go ahead and connect your battery. Alright. You're going to wait for the tones. And then you're going to stop it and let this find its spot. And then once you've done that, go ahead and click next. Your output calibration, you definitely want to make sure your props are off. And click next. Now my computer's not responding. Alright, there we go. Alright, for your output calibration, you're going to do motor 1 first. Click start. Alright, you basically want to bring this up to the point. You can use once you click the slider, you can use your arrows. Alright, so that's completely off. That's intermittent, and that's stable. So you want to go just at stable and then stop it. All of your motors should pretty much be pretty close to the same output values. So there's that one. Next, and number 3. And jump this on up to, that's off, intermittent, and that's stable. So there's that. Click next. Doing your servo, you're probably going to end up having to reverse it. I know I do. But basically the way you know you're going to have to reverse it is when you start this, when you drag this slider to the left, looking at your servo from the rear of the Tri-Copter, you want your servo to yaw to the right. with this top slider. Okay? And the way I like to do this, I like to use the arrows and basically throw it all the way to the point where I know it's the end of my throw, and then come back a little bit. About right there. And then your center. Obviously you want to get it center, so bring that over till it's center. It doesn't have to be exact, but pretty close, you know what I mean? And then go ahead and click next. Now I've done this with both the generic Tri-Copter tuning and the RC Explorer Tri-Copter tuning. I am using an RC Explorer Tri-Copter. Both of these were able to get me in the air and flying pretty much immediately, but I just kind of ended up redoing this whole process, and I actually prefer to start out with the generic Tri-Copter. That way you don't have anyone else's settings that you're not sure what they did or didn't do. Especially if you're new and trying to learn GCS, it can be a little bit confusing because you don't know what the actual default values are. So go ahead and just start out with the generic Tri-Copter. Once you get here, you're going to save. This is going to save all of those settings to your board. Once that's done, you're going to need your transmitter, because we're going to go through the transmitter setup. And mind you, my battery has been connected this entire time. Like I said, you want to make sure you have your props turned off. Alright, so we're going to do the transmitter setup wizard. Arming settings are now set to always disarm. You can change that later, but click OK. Go next. Acro, normal transmitter for fixed wing or quad. Then I'm at mode 2, which is left throttle and rudder, and aileron and elevator on the right. And then move your throttle stick just like it says. So my throttle stick, roll, and your yaw. Alright, you're going to toggle your flight mode switches. Just toggle it a couple times back and forth. This is going to be all optional, up to you, the way you have your transmitter set. Mine in particular, I don't have accessory 0. I do have accessory 1. It's tied to my gear channel. And, oh yeah, I've got it actually tied to my trim tab. And then I have no accessory 2. Center all your controls. If you're on your flight mode switch, make sure if it's any 3 position switches, make sure they're in the center. And then you're gonna move your sticks all over the place, and then go through your switches, flip them back and forth a couple times. Flight mode switch. And click next, and then you want to make sure that all of your channels are the correct way. So my yaw is reversed, my pitch is reversed, and my roll is reversed. So that's correct now. My throttle is right. Click next. And click next again, and then you want to come here and you want to choose which way you want to arm your board. I do roll left. Works pretty good. Save your settings down here, and then from this point we are going to go over to the vehicle settings tab. Change your roll, pitch, and yaw all to 50%. Alright. If your motors are not turning this direction, which obviously mine aren't, you can reverse your motors. You can save this and then go to your stabilization page. Alright. You want to leave basically all of these at default values. I actually, while I was doing my tuning, I added 5% of expo to my roll and pitch, and I added 2% of expo to my yaw. That'll kind of tune, or I guess it'll kind of settle down your responsiveness to your sticks. I don't like it to be so much so that I have to give a lot of input in one direction or the other to get my craft to respond, especially while tuning, because you're constantly, at least in my case, I'm constantly having to take my thumb off of my aileron and elevator stick, so for doing the TXPID. Once you get done with that, save, and then go over to your advanced tab, and you're going to zero out under your rate stabilization. You're going to zero out your integral and your derivative on roll and pitch both. You can leave your yaw settings at default values. Save that. And then we're going to go over here to TXPID. Now, in order to do this, you click Enable, and when you click Save, you'll notice this little X right here. You actually have to power cycle your board before this will allow you to set it up. So I'm going to disconnect, unplug my board. At this point in time, you can go ahead and disconnect your battery, and I'm going to replug my board back in. It should connect on itself. If it doesn't, you can come down here and click connect. Alright, now TXPID is enabled. Okay, so on the TXPID, your control source, you want to set it to whatever auxiliary knob or accessory switch that you have. I'll link a tutorial to setting up, if, like in my case, I only have switches. So I actually have my gear or accessory 1 switch. I have it set to my trim tab, so I can actually get the full throw of that channel in one increment, plus or minus. So accessory 1, and then instance, we're going to go ahead and do roll rate KP first. Alright, on your minimum and maximum values, you can leave the minimum alone unless you think you're going to need to go down on your values, but most likely you're going to have to go up. So what I do is I go over here, erase the 3 and a 0, and put 2, 0. Click save. Alright, we're going to go back to our stabilization tab. Alright, I'm going to power the CC3 back on with the battery, and then I'm going to test this. The only way you can test it is when the Tri-Copter is armed. So I'm going to go ahead and arm it, and then I'm going to check my trim tab. Now you can see right here on my roll proportional, I'm going to increase all the way up to 2000. So now I can decrease, bring this back to its neutral level, click save. That's done. Once you have that done, you can go ahead and power off your transmitter. You can click disconnect on your board. You can unplug your battery from your board, and you can also unplug your board from the USB. At this point, I'm going to kill this video, and I'm going to go outside and start tuning this thing. Alright, we're out in my garage, about to start doing this tuning process. I wanted to point out a few other things while I was here. I wanted to say first off that I really highly recommend you setting up a fail-safe switch on your transmitter to where no matter what you can kill the throttle. Secondly, I also wanted to say that I also highly recommend that you balance your props, and because the less vibrations the better tune you're going to get. Try and do this in as open of an area as you can. You don't want a lot of prop wash or prop push, whatever you want to call it. Basically where the air coming off the props is kicking up and disturbing the craft. It's going to give you false readings or numbers that are too low, and it's not going to fly as well. Last but not least, always make sure that your motors are spinning in the proper direction. Make sure that according to the GCS, your motors are spinning the way it thinks they're spinning, because that's going to give you a difference in your yaw and everything else. Because if they're spinning one way and it thinks they're spinning the other way, it's going to throw your I think it really just messes with your yaw. It's going to make it drift more. It's not going to be locked in filling. Also, make sure your props are on the correct direction. And then I also didn't go over this in the GCS, but your flight mode 2 switch should already be set up for attitude on roll and pitch and rate on yaw. That's what you want to do all this in rate yaw. Okay, if you do it in axis lock yaw, your yaw is going to be sitting there wagging, and you're going to be drifting slowly, so it's going to be a lot more difficult to control it. But if you do it in rate yaw, it should be locked in pretty much with the default settings. So the way I recommend doing all this is to go ahead and turn your knob up. Go ahead and go up, say, to 25 on your, well, let's see, you should be starting from -100, so go up to like -20 on your channel. Alright, and then go ahead and bring it into a hover from that point and see if you get any oscillations. Getting a little bit of oscillations, not very much though, so I'm going to go ahead and go up another 10 points. So I'm going to go to -10 on my channel and bring it back into a hover. Getting a little bit of oscillation, but I think that's from prop wash, so I'm going to go up another, I'll go ahead and go to center on that channel, so go up another 10 points. There. I'm going to go ahead and bring it up another 10, so I'm going to be +10 on my channel. Bring it back up into a hover. That's pretty steady right there, pretty steady amount of oscillations, but I'm going to go ahead and go up another 5 points, so I'm going to go to 15 on my channel. Bring it back into a hover. pretty good right there. So I ended with a positive 15 on my TXPID mix. I'm going to go ahead and try and get this filmed. You know what? I'll try and get it to where you can actually see the oscillations a little bit better. Try it right here. Hopefully that picked up the oscillations I'm talking about. It's going to be the same thing on the pitch axis. You're going to look for those same exact kind of oscillations. So don't power off the Tri-Copter. Don't move your auxiliary knob or your slider switch. Go ahead and lock, throw your safety switch on so you can't spin up your props. Grab your transmitter and your Tri-Copter. And we're going to go inside. Alright, go inside. Alright. Go ahead and plug your USB up. And then we're going to switch to the ground control station, and I'm going to show you what to do from here. Alright, we're back in the ground control station. Go to your stabilization tab, advanced, settings, make 1. Your Tri-Copter should still be powered on, and your transmitter should still be powered on. Make sure you do not touch your auxiliary knob. You're going to go ahead and arm your Tri-Copter. Once it's armed, you will be able to see what number your tune came out to be. So mine is bouncing between 1279 and 1281, so we'll go in the middle for 1280. Take note of that number. It's your roll UOV. Remember, this is using Cnut's method. We're going to use his UOV calculator or optune calculator, however you want to say it. So 1280 on my roll axis. All right. Once you've done that, go ahead and disarm your CC3D. You can go ahead and come over here. You want to set this back to default, your roll proportional, which was 0.00300. Go over to your let's see, go over to your TXPID. Oops. Make sure you save those settings. Go to your TXPID, and you're going to change this to pitch rate KP. You're going to have to reset your max again. Remember, go to the 3, go 1, 2, and then enter 20. So that gives you a value of 0.020000. Save that setting. Go back over to your stabilization tab. Rearm your board. And check and verify that your knob or your slider switch is giving you the complete throw and all the way up to 2000 and then all the way down to 300. Once you have that, go ahead and click save again. Nope, I'm sorry. You have to disarm. Disarm, click save. And then you can go ahead and disconnect your CC3D from the computer. And we're going to go ahead and head back out in the garage, and we're going to tune the pitch proportional value with TXPID. Same way we did it earlier. Like I said, if you want to go ahead and bump your channel up, I'll just show you on this. You want to go ahead and bump your channel up to about, we'll start at -20 again. So do that, bring it up into a hover. increase again. I'm not really getting very much oscillation, so I'm going to go to -10 and bring it back into a hover. Still not getting very much, so I'm going to go ahead and go to 0 or centered. Still not getting much of anything, so I'm going to go ahead and go up to +20. Go to +30. Still not getting much. Going to go ahead and go up to +50. Starting to see some oscillations right there, so I'm going to go up to +60. So a little bit progressively worse. Go ahead and go up to 65. Go ahead and go up another 5 points to 70. That's pretty much spot on, but I'm going to go ahead and go up another 5 points to 75 and see what it looks like. Alright, I'm going to stop there at 75. It's giving me pretty good oscillations. I actually maybe could go up to 80. Let me go up to 80 and see what 80 does. Actually, I like that better. I'm going to go with 80 on that. So remember, don't power off your tricopter. Don't turn your transmitter off. Make sure to hit your safety switch so you can't spin your propellers up. I'm going to go back in here to the GCS again. So, same as before, go ahead and plug your board in. Once you get that plugged in, I'm going to switch back over to the GCS. Back in the ground control station. Got the flight controller hooked up. We're going to arm the board. Alright, looks like my values are between 1833 and 1831, so I'll go in the middle of that with 1832 for my pitch UOV. So 1832. Alright, now we're going to go, once you get done doing that, you can go ahead and disconnect your flight controller. You can unplug your battery pack, turn your transmitter off. Go ahead and set that stuff off to the side. We're going to go into our Internet Explorer, web browser, Google Chrome, whatever you're using. Once you're in your web browser, just Google search optune calculator. It should be the first one that comes up. I went ahead and pre-entered the numbers on a separate tab because for some reason when I enter numbers with this screen recorder I'm using, it flashes black. So anyways, enter your roll UOV 0.01280, your pitch UOV 0.01832. Make sure you have no keep roll and pitch separated checked. Click calculate, and then you'll get your PIDs right here. Alright, so there it goes. Alright, so roll is 448, 717, and 36. Pitch 641, 1026, and 51. And then yaw 1120, 1792, and 90. Once you get those numbers written down, you can go ahead and close out your web browser and head back to the GCS, and we'll go from there. Go ahead and reconnect your board, get back into your OpenPilot GCS, and then under your settings, Bank 1, Advanced tab, what we've been under the whole time, you're going to enter those values into your rate stabilization PIDs. So we got 448 and 641, and then 1120 on the yaw roll and pitch PIDs. 1120. Here in integral, enter those in. Oops. And then your derivative, 36, 51, and 90. Alright. Save those settings. Go to your TXPID, and you want to disable your instance 1, the one we've been using to do this programming. You can leave the module enabled, that's fine, but just make sure you disable these so that accessory switch is not tied, and that way it's not going to change your settings once you get them. Yep. Make sure you save it, and then go back over to your stabilization. Just go through, double check your numbers, make sure they're correct. You can go to your basic tab and you can change your expos if you want to. For now, I'm going to go ahead and leave them the same. I'm going to leave my responsiveness the same. And then if while you were tuning you noticed that you were getting drift, like actually while I was tuning I was getting back drift. So if you want to try and recalibrate your gyro and accelerometer, that's up to you. Or if you want, if it seems like it's not very bad and it's something you can adjust, you can actually go into your system, go to settings, go to attitude settings, board level trim, and then your roll and pitch axis. So if it's drifting back, that's going to be your pitch axis. If it's drifting back, I believe you would go positive numbers. If it's drifting forward, you go negative numbers on the roll. If it's drifting to the left, you go positive numbers. If it's drifting to the right, you go negative numbers. Go ahead and I'm just going to start out with 10 and try that. Come up here, click save. Once that saves, you can do whatever else you need to do. go ahead and disconnect your board. And I'm going to go out into the garage and show you guys what these numbers do. Alright guys, we're back in the garage. We've done our we've got our UOV numbers for pitch and roll through TX-PID using Cnut's tuning method. A slight variant of it, but basically the same. Now, this next step, after I show y'all what these numbers that we just got end up doing, what I've done extra or additional is, now what I do is I take the yaw numbers that I got from the calculator and I enter those in as my default numbers, and I redo the tuning process all over again. Alright, the reason for this is because your default numbers most generally are not perfect. They're going to give you a little bit of drifting. Axis lock definitely does not work as it should. But you'll actually see right now, as I'm going to show you, that I'll show you in rate first, and then I'll switch over to axis lock, and I'll show you that it's not exactly perfect. So if you take these numbers that you got from the calculator in your yaw, redo this process that we just did, and get you a completely whole new set of numbers, and those, for the most part, from what I can see, as that's my process and that's what I'm flying with currently, it seems to be the best that you could probably get for just your average good flying tune. Now, if you were anal about things and you wanted to go in and fine tune everything, that's your prerogative. But for me, the numbers seem to work pretty good, as you're about to see. So there we go again. Bring it into a hover and show you guys. Alright, so see, this is basically drifting, like I said before, but this is hands off right here. Hands off. Don't try that at home. I'm going to switch over to axis lock real quick. Show you what axis lock does. I like flying in rate yaw better than I do an axis lock yaw, because rate is locked in, it holds true. It's snappy, it's effective. I don't know why axis lock, I still haven't been able to get it to work perfectly, but here's what I picking that up or not, but I'm not getting any wagging. But under input, when you release the stick, it has a little bit of where it's trying to find center before it actually locks in place. In rate yaw, it does not do that, but in axis lock, it will do that. And like I said, I have not been able to figure out how to tune that out. So, but guys, that's basically it right there. I will go in and explain what I was talking about just a minute ago, but I'm not actually going to go through that process. It's pretty much self-explanatory from this video of what steps you're going to end up having to do. And I hope everything helped. I hope this can help get people's tricopters flying and recording and doing flips and tricks and everything else, and whatever else y'all need to do with them or want to do with them. So I hope it helps. Thanks guys for watching. Alright, so in regards to what I was talking about in the last video I made of the garage, after we got our numbers, you can simply take your yaw numbers that you got from the calculator, leave those inputted in, and then reset your roll and your pitch values to the way we did this all over in the beginning. Zero your integral, zero your derivative, go into TX-PID, reset up your roll rate, KP, accessory, change your maximum value, to 20,000, and then take it out, retune it, bring it back in, get your UOV number for roll, and then change it to pitch rate KP. Same thing, set your maximum to 20,000, and then save that, take it back out, get your UOV for the pitch rate KP, and then re-enter those numbers into the calculator and get you a full new set of numbers. And the reason why I'm saying to do that is because your Tri-Copter values are going to be slightly different when you actually have a yaw setting that works properly. Alright, you're still going to do all this stuff in rate yaw. I haven't actually tried it in axis lock yaw to see if it gives me, again, different numbers on the pitch and rate, or the roll rate and the pitch rate KP UOVs, but it may very well allow axis lock to get a better number to work better. I've tried tuning axis lock individually in KP and KI on the yaw with the TX-PID by going in here, setting up yaw rate KP, bringing it into a hover, adjusting those numbers until I got something. Pretty much I never could really find a good locked in feel for axis lock. So that's that, guys. Hopefully this tutorial has helped you. It's really based towards people who are just getting into the CC3D, but I'm sure it can also help experienced pilots who already kind of know tuning and PID numbers. If there's any things you'd like to ask, questions you'd like to ask, or comments, criticisms about the video, about the information I gave, feel free to ask. You can PM me on Open Pilots. My username is Override. Well, I hope this was able to help somebody. I'm going to go ahead and get off and put this video together and get it put up on the forums. Thanks, guys.